Good morning, everyone. I'm Dr. Shenjiang Wang. Today, my topic is Introduction to Electron Microscopy. As an engineer, you may be interested in why Coca-Cola uses three kinds of material for package: metal, aluminum can, ceramic, glass bottle, and polymer, PET bottle. The three materials show different kinds of the property. The aluminum can is solid and ductile. The glass bottle is transparent and strong, but brittle. The polymer is flexible and lightweight. It's due to their intrinsic component, the alumina element, silicon and oxygen, and the carbon and hydrogen elements. In here, I would like to give you another example. The alumina containing elements of the aluminum and oxygen. The material can be transparent, semi-transparent, or opaque by different processing. The transparent alumina is sapphire crystal. You can find it in your Apple Watch. It's very hot and used for scratch resistant. The semi-transparent alumina can pass through parts of the light. The opaque alumina, as you can see in the slide, used in a spark for insulator in white colored. The three kinds of alumina has the same component but different orbital property. Why? The reason is the structure is different. More precisely, different microstructure called grain size. The sapphire crystal is a single crystal. The atom arranged periodically across the whole valence. The semi-transparent alumina contains small parts of the area, which the atom arranged periodically across each small area, called grain. The third kind of the solid is amorphous, atom arranged randomly. The imperfection structure will scattering the light and change its orbital properties. Besides the composition and grain size, there are many microstructures that can influence the property of the material, including crystalline size structure, which means the atom stacking according to a body center cubic order of the FCC or HCP order, the crystalline defect, the imperfection of the crystal, phases, interface, orientation, inclusion, and even internal stresses. Today, the material we're interested in is changed a lot. The slide shows the scale of things, nature or man-made. Human can produce things smaller and smaller, from millimeter scale to micrometer to the nanometer. We call this centering is the narrow edge. It means we can control manipulation and integration of the atom according to our definition. But how small is narrow? If I use an ant as a reference, it's a 4 millimeter long. If I enlarge 1 million times, its length becomes Indianapolis motor sideway 4 kilometers. In the same idea, if 1 million times smaller than the ant, it is a 4 nanometer nanoparticle in diameter. The question is how to observe that, or how to observe the structure in narrow scale. The nano size is smaller than the resolution of naked eye, so we need a tool to help us to see the narrow things. The tool is microscopy. The word microscopy is derived from the Greek micros and scopio. Prefix micros means small. Suffix scopio means look at. By the help of microscopy, human is able to look at the smaller and smaller detail of the world around us. For example, biologists has want to examine the structure of cell, bacteria, and viruses. Material scientists has want to see the inhomogeneities and imperfection in the metal, crystal, and ceramic. The academic definition of microscopy is an orbital system which transfers object into an image. In general, we magnify the image much larger than the object. How microscopy works and how to interpret the image to object are two key points for learning this knowledge. Microscopy can be classified as three types: orbital, charged particle, and scanning probe. Orbital microscopy are the most familiar to everyone. They use visible light and transparent lenses to see the object. Their magnification is about 1,000 and enable the eyes to resolve objects separated by 200 nanometers. Electron and ion microscopy use electron or ion particle instead of light and use electromagnetic lenses to focus the particle. They can see the object as small as tenths of nanometer, such as the individual atoms. Scanning probe microscopy uses a physical probe, a very, very sharp needle, which can be scanned over the sample surface. The interaction atomic force between the probe and the sample surface are recorded as the image. The SPM tools are capable of atomic scale resolution. Why we use the electron to instead of visible light to see the object? The relationship between resolution and wavelength can be described as diffraction limit or Rayleigh criteria. When a wave passes through an opening in a barrier, as an aperture in a lens, it is deflected the edge of the aperture. Aberration is formed. According to the equation, the resolution is proportional to the wavelength of light. It is the physical resolution limit for an orbital system. So if you want to improve resolution, using shorter wavelengths can get a clear image. For example, compare the transmission electron microscopy (TEM) and the orbital microscopy. They have the similar component: illumination source, condenser lenses, sample, objective lenses, and projecting lenses, and the photographic plane. If the wavelength lambda equals 550 nanometer, the semi-angle is about 1. The resolution of the orbital microscopy is about 330 nanometer. Regarding the TEM, with the 100 kilovolt accelerated voltage, the wavelength is about 0.0037 nanometer. The semi-angle equals 0.1 radians, and the resolution is 0.02 nanometer, 60,500 times better than the OM. Here I would like to show you some typical image of the microscopy. Here is an image of the TEM. You can see a grand boundary of the gold, and the gold atom can be seen clearly. The right side shows the Ebola viruses. Here shows the SEM or FIB image. You can see the image a very similar like a human eyes to look at. Here is the Bumblebee antenna and the logic device in the right side. And scanning probe microscopy, we can see the probe to manipulate ion atom as a circle. Finally, I will give you the summary. After this lecture, I hope you got some idea that why electron microscopy is important for today's industry and research, the type of electron microscopy, the resolution of the microscopy, the image of the microscopy, and he will show you and unsee the world. And thank you very much for your attention.